So yesterday we learned what a quadratic function is. We learned about the key features of it. We learned about our zeros, how to find our zeros, our x-intercepts. We learned about y-intercepts. We learned about the vertex. We learned about the axis of symmetry. We learned about all of those things. We learned about symmetrical pairs. Today we're going to learn how to figure out whether you have a quadratic function. So it's easy to tell by looking at a graph, but we're going to learn about what happens when I'm looking at some other type of thing too. So we're going to start by reviewing graphs because they're either. So right now we have three types of functions. They're either linear, quadratic, or neither. All right, so the first one is linear because a linear function makes a straight line. Okay, a straight line. Okay, a quadratic function makes a parabola. Not a parabola, it's not Ebola, it's a parabola. That's how you say it. That's an H. Parabola. Okay, so it makes a parabola. Now, if you see something else, it's neither. All right. In this case, this is a cubic function. That is somebody else's problem. You're going to learn about that in algebra 2. But if you see something else, it's neither linear nor quadratic. We're going to learn one more function type before the end of the year, exponential, but this is not one of the ones we'll learn. So we'll do this again when we get to the end with exponential functions. All right. So now let's look at the equations. Okay, so to figure out whether something is linear or quadratic, so again, the first column is linear. So this is a linear function, okay? To figure out whether something is linear or quadratic by looking at the equation, we have to pay attention to the exponent. Okay, so what you may notice is that there is no exponent here. But that's not true. There's actually an invisible 1 exponent. Okay? When you have the highest exponent, is 1 or invisible, then you have a linear function. Okay? Now, if you notice on this one, the highest exponent I see is 2. So for quadratic, the highest exponent is 2. Okay? So for the linear, my highest exponent was 1. For quadratic, my highest exponent was 2. And if you see a function where the highest exponent is something else, then you have neither linear nor quadratic. Okay? So you're either going to have highest exponent of 1, 2, or something else. Okay? 1 is linear, 2 is quadratic. Okay? Now the last way we can tell something is by looking at the tables. And for this, we're going to have to do something that we haven't done before. Okay? So let's review with the linear function. So this is my linear function. Okay? So I have a constant, I'm going to have a constant rate of change. And I'm just going to put ROC for rate of change. Okay? So if I look at this, I'm going down 1, down 1, down 1, down 1. Here I'm going up 1, up 1, up 1, up 1. Well, negative 1 over 1 for this one, I'm always going to have a rate of change of negative 1. Okay? So I have a constant rate of change in this table. Now let's look at this one. Okay? We'll come back to this one. Okay? When I look at this one, if I look, let's just look over here. I'm going up by 1 in every one of these x values. Now here I'm going down by 3, up by 3, up by 5, up by 7, up by 9. So I don't have my delta y, so this was delta y, right? My delta y is not constant. But let's try going out one more. My second delta y is the same, okay? So for this one, my delta y2 is the same for every row. And we call delta y2 second difference. Okay? We call that the second difference. Okay? So over here, if we call this the second difference, what do you think we call this? We call it the first difference. So for this one, delta y is the same for every row. Okay, and now this only works when delta x is 1. Okay, other than that, then it gets a little crazier. Okay, and then we call delta y is the first difference. That looks like first. That's F-I-R, not F-R-I-R-S-T, the first difference. Okay? Now, if we see something completely different, like over here, I see, so these are all plus 1. So I can check like this. Now I've got 4, 16, 34, 58. Okay, well, the delta y is definitely not the same. So delta y1 is not the same. Let's try delta y2. Well, 4 plus 12 is 16. 16 plus 18 is 34. 54 plus 24 is 58. Delta y2 is also not the same. So it's neither if delta y1 and delta y2 are not the same. Okay? So that's how we tell by looking at graphs, tables, and graphs, equations, and tables, whether something is quadratic or linear or neither. We will talk about this more in class tomorrow.